NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth.
For decades, Voyager 1 has been sailing through the vast, dark ocean of space, carrying with it the hopes of generations of scientists, astronomers, and dreamers. Launched in 1977, its journey took it past Jupiter and Saturn, where it captured breathtaking images and data, then outwards toward the boundary of the solar system. In 2012, it made headlines as the first human-made object to enter interstellar space, crossing the heliopause, the invisible frontier where the solar wind from the sun is no longer strong enough to push back against the interstellar medium. But just recently, Voyager 1 sent back data from this distant edge that shattered assumptions long held about this boundary region and confirmed suspicions that had been largely overlooked or dismissed for years. The implications ripple not only through astrophysics, but through our fundamental understanding of the solar system's interaction with the broader galaxy. Before we start, smash the like and subscribe buttons for more updates. What Voyager 1 confirmed was both monumental and quietly unsettling. At nearly 15 billion miles from Earth, beyond the heliopause, it encountered a persistent structured hum, a low-frequency plasma wave vibration, unlike anything detected before at such distances. This constant vibration was unlike the transient bursts of plasma waves Voyager 1 had previously recorded as it passed through solar eruptions. Instead, this was a steady, omnipresent signal, a kind of background music to the void. For years, scientists believed the region beyond the heliopause was largely silent, except for the occasional solar storm crashing into interstellar particles. The dominant model proposed a bubble-shaped heliosphere with a clear and abrupt transition into interstellar space. But this steady hum contradicted that simplicity. The plasma hum confirmed something crucial. Interstellar space is not silent, not static, and certainly not empty. Instead, it is dynamic, alive with low-level energy that fluctuates in ways we are only beginning to understand. This hum is thought to originate from the movement of interstellar plasma, charged particles that pervade the galaxy, vibrating as they interact with the local environment. What made this confirmation extraordinary was how it fundamentally altered our perception of what lies beyond the sun's influence. The expectation of an inert dead space was replaced by a vivid realization that the medium between stars is far more active and responsive than imagined. Even more intriguing was the nature of the plasma itself. The detection of this steady vibration suggests a higher density of interstellar plasma than models had predicted. Previously, it was assumed that once Voyager 1 exited the heliosphere, it would enter a region of vastly reduced particle density. Instead, the plasma environment was thicker and more structured, indicating that the heliopause might not be a clean-cut boundary at all. Rather, it's more like a turbulent shoreline where waves of solar and interstellar material clash and mix. The transition is not as straightforward as crossing from air into water, but more like navigating a foamy, roiling surf zone. The edge of the solar system is not a line, it's a storm. For a long time, a minority of researchers speculated that this region might be more complex than the dominant models allowed, suggesting layers of magnetic interaction and particle exchange between the heliosphere and the interstellar medium. These ideas were largely seen as speculative or unnecessary complications. Voyager 1's data, however, has vindicated them. What had been ignored or brushed aside is now unavoidable. The implications are significant, particularly when considering how the sun's influence wanes and how galactic forces begin to take over. It turns out the solar system doesn't end in a neat boundary, but gradually blends into the broader galactic sea, with particles and fields weaving together in complex patterns. The confirmation also revealed something unexpected about the solar system's shielding ability. The sun's magnetic field, carried outward by the solar wind, was thought to form a protective bubble around the planets. Voyager 1's discovery suggests that the boundary of this shield is more porous and unstable than expected. Cosmic rays and interstellar particles may infiltrate the solar system more easily, subtly affecting everything from planetary atmospheres to the behavior of spacecraft. It raises profound questions about how Earth and its neighbors are protected from, or exposed to, the galaxy's raw environment. Voyager 1's signal, faint and delayed by more than 21 hours of travel time each way, continues to deliver revolutionary insight from a spacecraft the size of a small car, powered by a radioactive heart and primitive computers. Yet the information it beams back is reshaping the architecture of heliophysics. The discovery of the plasma hum, its consistency and its implications suggest that the edge of the solar system is less a border and more a frontier, a complex active interface zone between solar and galactic phenomena. And this discovery hints that there may be layers of structure beyond what Voyager 1 can detect, possibly nested transitions that blend more subtly from solar influence to galactic dominance. This brings attention to the broader question of how our sun is embedded in the galaxy. The interstellar medium is not a uniform mist, but a chaotic sea of gas, dust, magnetic fields, and radiation. It flows and shifts as the galaxy rotates and as nearby stars explode and release waves of energy. The sun is currently traveling through what scientists call the local interstellar cloud, a wispy region of relatively warm gas. The nature of this cloud and how it presses against the solar system's outer edge plays a crucial role in shaping the heliosphere. Voyager 1's findings suggest that these interactions are more intricate than imagined, hinting that local galactic conditions might influence the solar system far more than we thought. Moreover, the hum confirms that the boundary region is not only shaped by the sun pushing outward, but also by the galaxy pushing inward. It's a region of collision, negotiation, and turbulence. As Voyager 1 drifts further, it continues to pierce through the outskirts of this interaction zone, providing a cross-sectional reading of how the solar bubble bends, warps, and leaks into the interstellar domain. In doing so, it shows that the solar system is not an island, but part of an archipelago of cosmic interactions. The heliosphere doesn't isolate us from the galaxy. It is a membrane, porous and dynamic, filtering and reshaping external forces as they flow inward. Perhaps most fascinating of all is the potential that Voyager 1's confirmation opens up regarding the architecture of other stellar systems. If the sun's outer boundary is complex and turbulent, what does that suggest about the heliospheres of other stars? If plasma vibrations hum in the vastness beyond our star, might similar frequencies emanate around distant suns? And if so, could those signatures be used to detect or analyze other stellar systems from afar? Voyager 1's findings become not just a revelation about our own solar neighborhood, but a template, a reference point, for studying the environments of other stars across the galaxy. The discovery also forces a reconsideration of interstellar travel itself. For any future mission designed to leave the solar system, understanding the nature of the heliopause is essential. The misconception of a simple exit point gives way to the reality of a dense, energetic, and possibly dangerous environment. Navigation, shielding, and communication systems must all be re-evaluated in light of this plasma activity. Voyager 1 has provided a glimpse of the challenges that lie ahead for humanity's greatest dream, venturing beyond the sun's reach. Yet there is also a poetic dimension to this moment. A spacecraft launched over 4 decades ago, running on ancient technology, barely alive by today's standards, has sent back a message that upends our understanding of where we belong in the cosmos. It confirmed what many refuse to consider, that the edge of the solar system is not a barrier, but a dialogue, one written in particles, fields, and waves. Voyager 1 has become our first ambassador to the stars, and with this recent finding, it speaks with a voice we are only just beginning to hear. The story of this confirmation is a quiet revolution. It didn't come with flashing lights or dramatic cosmic events. It came as a persistent, ghostly signal, plasma humming across the darkness, so subtle that it might have been missed entirely if not for the patience and precision of those who interpreted the data. This hum doesn't announce itself. It waits to be understood, and in that waiting, it offers something profound, evidence that the universe is never still, even in its loneliest corners. Voyager 1's discovery at the edge of the solar system marks not an ending, but a beginning. It is the first real peek into the galactic space beyond our solar cradle, and it shows that space is more textured, more vibrant, and more alive than previously imagined. The interstellar medium is not just a background, it's a player, a force, a living field of energy that shapes everything it touches. This hum of plasma, seemingly small and overlooked, is a profound statement from the universe itself. That even in the most remote and quiet places there is motion, vibration, and change. As Voyager 1 continues to drift, its instruments aging and its systems fading, its legacy only grows stronger. The mission's latest finding compels a re-evaluation of countless models and assumptions. The edge of the solar system, long thought to be a clear boundary, is now revealed as a complex transition, a vibrant active interface that pulses with energy. This challenges the static view of the solar system's periphery and encourages a new way of thinking about space as fluid, interactive, and evolving. In the years to come, new probes may follow Voyager's path, armed with modern instruments and faster trajectories. They will go further, measure more precisely, and delve deeper into the galactic medium. But they will do so with Voyager's data as their guide. The plasma hum will be a signal to follow, a marker of where the sun's influence ends and the galaxy begins. It is a signature of that great unknown, now slightly more known because a tiny craft, powered by the decay of plutonium and guided by 20th century math, whispered back across the stars. Voyager 1 confirmed what was always there but never truly recognized, that the edge of the solar system is not a void, not a silence, but a complex symphony of energy. It showed us that even in the outermost reaches, the universe is communicating, waiting for someone or something to listen. This is not just a scientific finding. It is a new lens through which to see our place in the cosmos, not as isolated or sealed off, but connected, entangled, and vibrating with the same currents that flow between the stars. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 1's new discovery at the solar system's edge? We want to hear from you. Thank you for watching, and see you next time.